talk about what is density. So the formula for density is quite simple. It is mass divided by volume. However, you sometimes are not provided the mass or the volume, but you might be provided the density, and then you have to solve for one of the other ones. So there's a very simple way to do this. And I went ahead and I drew a triangle. And within this triangle, the pink line is going to represent division, and the green line is going to represent multiplication. So when it comes to the letters that you see here, we will have, and sorry, let me do that line again. So the green line is representing multiplication. Okay, so when we have the letters, density is going to be represented by D. So D is representing density. M is going to represent mass. And V is going to represent volume. Now, when it comes to the unit of density, I'll do those in pink. So units of density would be grams over centimeters cubed, which you would have to raise this. So normally we'll put a little dash like that. Or you can have grams over milliliters. And the reason why is because for 1 centimeter cubed, it's identical to saying 1 milliliter. So normally you're measuring centimeters cubed when it comes time to measure an object, and that object happens to be a solid. So in such an example, let's say we have our solid. In order to calculate for the volume of a solid, you would do length times width times height, because that's how you would calculate the solid object. When we're looking at an irregular shaped object, then we're going to use an entirely different process called water displacement, which is when I put an object inside water that had already been measured, and the water will rise in a graduated cylinder, and what our outcome milliliters is would be subtracted from the original. And that's how we would determine the volume of a shaped object that is irregular. But back to the triangle, I gotta add mass at the top. I'm gonna do let's see, like blue for mass, and then over here I'm gonna have volume. I'll do in purple. Raise it a little. See if it lets me here. All right, so this is our triangle. So why is the triangle in this shape? Very simply put, the pink represents division and the green represents multiplication. So when you're given a variable that doesn't have the other one, we have to alter this formula. So we use that triangle to come up with our new formula. So for example, let's say they gave me volume and they gave me mass. What is my formula? Well, you go up here and you look at the triangle. And so they gave you volume and they gave you mass. Then you're calculating for density, which is our original formula. Well, what if I change it up? And this time instead, they gave me density and mass. So they gave me both the blue and the black. So the density and mass are given, but not the volume. Then at that point, I would look at the formula and I would notice that they gave me density and mass, and I need to identify the volume. So my formula would be volume equals mass divided by density. So my volume would be equal to the mass. Sorry, the line here. Mass divided by density. So right there you can see how we're using this triangle to come up with that information. Now, how about they got rid, oh, went too far, of that, and instead this time around, I'm doing green, they give me the density and the volume. So they gave me density and volume, but they didn't give me mass. Well, in such a situation now, it would be mass is equal to density multiplied by volume. Remember that green represents multiplication. And to recap, in pink, had they given me density and mass, and they told me find out volume, my formula would have been volume is equal to mass divided by density, because this line represents division. However, if they give us our original, which is they give you your mass and they give you volume, and you got to find density, then you take the mass and you divide it by the volume. And that is essentially how you use the density triangle formula. So recap, the pink line means division, and the green line means multiplication. So this triangle allows you to know all three formulas without having to memorize all three formulas. Now the unit of mass is going to be represented in grams most often, or you might see it represented in kilograms, kg. And volume can be represented in centimeters cubed. Remember, that's because you multiply length, width, and height. So let's say I have a box and I'm measuring the length, the width, and the height. Whatever unit you're using, which is most commonly using centimeters, you're essentially multiplying whatever the length is. Let's say it's 1 times 1 centimeter for width. So 1, and let's make height 2 times 2 centimeters for height. And you're going to end up with that unit being cubed because you've multiplied it 3 times. It accounts for 3 sides. And it would be 1 times 1 is 1, and 1 times 2 is 2 centimeters cubed for the volume of this example here. So another way, unit-wise, is milliliters. And sometimes they might even give it to you in meters cubed. So once again, the units of volume are most commonly represented in centimeters cubed, meters cubed, and milliliters. The unit of mass is represented in grams or kilograms. The unit of density is represented by grams divided by centimeters cubed, because once again, that's your mass. Your mass divided by volume. Or you could literally write it as grams divided by milliliters if they have given you a liquid. And to use your triangle, anytime you want to identify mass, you will then be multiplying density and volume. Anytime you want to represent volume, so this one, you will take mass and divide by density. And anytime you want to represent density, this one, you take the mass and divide by the volume, which is what I have as my original formula. And last but not least, just a quick reminder that when it comes to the unit, 1 centimeter cubed is equivalent or the same thing as saying 1 milliliter. So why use them? You normally use centimeters cubed when you're dealing with a solid shaped object, and you use milliliters when you're measuring an object that is irregularly shaped in liquid. And then you will see the water displace, meaning it'll grow up to where it needs to. And then at that point, you can subtract it from the starting point and you'll know the amount of milliliters or volume that object has.